going to attempt to cover a whole lot of projects in about 10 minutes, so if it seems like I'm rushing, it's because I really am. And before I get into some more kind of details of what we've been doing, I just want to give an overview of epidemiology and what we're doing here at Harbor Branch. Specifically, in case you don't have any background or don't know what epidemiology is, and you're like a lot of my family members who think I study skin, that's not what I do. So if you have any weird rashes to tell me about or show me, I don't want to see it. Just as a primer there, my aunt really ruined Thanksgiving last year for me, so it's followed by no eye contact Christmas. So let's go to some specific work. I talked about this stuff a little bit last year if you came to our talks, and I don't want to rehash it, but I do want to give a slight update because it's some really interesting work that we've been doing, Peter McCarthy and I have. And we've started looking kind of at a different line of research with lobomycosis, which is actually is a skin disease that we've seen in dolphins, but it's only been documented in dolphins and humans. And we've started this new collaboration with a physician in Brazil. That's the only area where it's actually endemic to human populations. So we've actually gotten human and dolphin bits, as Peter likes to say, and we're comparing them in the lab from a molecular standpoint with the hopes of developing environmental probes, so a way to look for the actual fungus, the causative agent itself, in the environment, both human and dolphin areas. And that's important not only for the environmental aspect, but also because there's this potential or perceived potential zoonotic risk of transfer of lobomycosis from dolphins to humans. But we actually just published a paper recently in the past year describing really the lack thereof of evidence of human transmission from dolphins. We continue to do a variety of infectious disease research projects. Many of these diseases, at least the ones that I focus on, are also pathogens that can affect humans. So toxoplasma, which is a particular issue for pregnant women, and its primary host here, or reservoir, are felids, so cats, both domestic and wildlife. And we've documented that in the Indian River Lagoon dolphins. We also look at a variety of vector-borne diseases. For example, West Nile virus, which was the first time it's been reported in a cetacean population. And it has this shared vector of a mosquito. And believe it or not, dolphins do get bit by mosquitoes, and we've seen evidence of exposure. And then the most recent work, the most recent publication, was actually on chlamydia in dolphins. And if any of you are familiar with dolphin behavior, it probably doesn't surprise you that we've seen chlamydia in these critters. They make some of my fraternity brothers look really picky. And as a matter of fact, what we've seen is not necessarily overt clinical disease, but some of these animals have a subclinical infection, which means they're probably just carriers of chlamydia and spread it throughout the population, which is going to lead us, or has already led us, down the road of doing some really interesting infectious disease modeling work. And then stress response. Now, this is a collaborative project which we've leveraged SLP funds to get some funding from the Office of Naval Research. And when I talk about looking at the pathophysiological effects of stress, I don't mean stress as in you've got bills to pay, deadlines at work, or your dolphin baby mama's hooking up with 6 other guys. It's really the fact that we're looking for environmental stressors. And to do that, we're comparing multiple populations of varying kind of conditions. First off, the Georgia Aquarium, which is obviously a very controlled setting in terms of water quality, what these animals are getting fed, their activity level. And then we have the U.S. Navy Marine Mammal Program that's out in San Diego. We're comparing those animals because they're managed care, but they're also in open water pens, so they're exposed to a variety of environmental stressors. And then we have our wild dolphins, both in the Indian River Lagoon as well as Charleston Harbor, which has served as our comparison site for a lot of other work. And what we want to do, and what we're continuing to develop, are these models where we're looking for associations between environmental stressors and markers of stress with endpoints that include inflammation, hormone production, and a whole variety of immune responses. And this is a ton of data. So I'm not really going to present any of it, but we're seeing some very marked differences across these 3 populations, both in terms of marked decreases in immune response as well as actually hormone production. And then mercury research, which has been a focus and gotten a lot of attention lately. We've previously documented that dolphins in the Indian River Lagoon have a high mercury concentration, some of the highest that have been reported in a cetacean population. And that's led us to a variety of research projects, which includes looking at more of the pathophysiological effects of high exposure. So these animals have marked decreases, at least in markers of liver, kidney, and even endocrine function, as well as changes in their immune system, so their ability to fight off common diseases and pathogens that are found in the environment. So the next step to that, this is some work that's actually in co-author review right now. We wanted to look at this question of whether or not we've seen changes in the mercury concentrations over time. Are there differences in terms of the spatial distribution? And then some really interesting work with Elizabeth Murdoch-Titcomb and the photo identification group to look at social affiliation and clustering of animals that are highly exposed. So a quick look at the results is that we actually haven't seen a change, a marked increase or decrease in the mercury concentrations of the dolphins over time, which relates a little bit to the routes of exposure in terms of atmospheric deposition of mercury in Florida and a variety of other environmental conditions. We're hoping to answer that a little bit more specifically by using some of the environmental data that's being collected by Dennis and his group with the Lobo units and a variety of other sources. But we have seen a little bit of a difference in terms of the spatial distribution where animals, this is based on photo ID data, who spend a lot of their time or most of their time up in the northern area of the lagoon tend to have a higher concentration of mercury. And that's both in the blood and the skin. And to validate that, that's where we pulled in some of this social affiliation data. And I know it just looks like a bunch of random dots, but this is actually based on the photo identification sighting histories of individuals. So we wanted to look at if the animals that are the highest exposed critters, which we took the 90th percentile, if those animals were highly affiliated with each other, and then if that social group had a specific affiliation in terms of spatial distribution. So it kind of matched what we saw in terms of animals that spent their time in the northern section. So these are, in red, the animals that had the highest concentrations and their relatedness to each other. And then when we threw it in the entire IRL population based on the sighting history, you see that they're still clustered together, and that clustering is statistically significant. But I know it just looks like a series of dots. But we're actually working on this publication, and hopefully that'll be out soon. And a follow-up, I skipped one of my earlier slides, but one of the main goals of the epidemiology work is to connect this concept of dolphin, environmental, and human health and kind of complete the loop. And an example of that is, again, the mercury research, which we recently published a paper where we screened residents of Florida, particularly people who lived along the Indian River Lagoon, and used the waterway for fishing and recreation, a variety of activities, and measured their mercury concentration in their hair. We did that related to their fish consumption. We did a very comprehensive survey of what they were eating, where it came from, and how often. And we found that individuals who reported consuming seafood, particularly locally caught, 3 times a week or more, had a significantly higher mercury concentration. And that's actually seen right here. 4 times more likely to have what we consider, at least the EPA considers above a threshold for safe consumption, which is 1 part per million. And I haven't, oh, there's a sign, thanks Mary. I keep saying we during this talk, and it's not because I have multiple personalities or anything, it's because we have a ton of really important collaborators, both internally and externally. Some of them you've already seen talks from, like Peter, the photo identification group, as well as all the genetic work, which we hope to integrate at some point later on down the line, which is pretty interesting as well. And then our collaborators with the Georgia Aquarium, where we've also gotten some funding to do the human work, and a variety of other folks that are way smarter than myself and make this work possible. And I think I'm on time.